Am I audible to both of you?
Yes, I was.
Okay, so can you tell me in the last class with Salim sir, what was the topic of this alcohol?
So the last topic we did was electrophilic aromatic substitution. And then we did bromination and nitration. And then we did questions.
Okay, so let me ask you some question. Electrophilic substitution, right?
Yes, of aromatic.
Of aromatic. Is it ether started or not? Electrophilic substitution of aromatic of what? Alcohol, phenol.
Yes, sir. We didn't start either.
Okay, okay. That means basically you are done with halogenation, right?
Yes, sir.
And coal-based reaction, Remer-Tiemann?
No, sir.
No, not yet. Okay, no problem. Okay. So this is the question of conversion. You are going to convert it. The first is basically one phenyl ethanol. You need to prepare one phenyl ethanol from an alkene, suitable alkene. I think you can is. I think I had given this question, right? Yes or no? Let me just check it. This is a very no, here. In other batch, JE batch. Okay, so this is the conversion. You need to prepare this one phenyl ethanol from an alkene. Very simple it is. What is the batch name of your batch? For Salim sir?
That's C3.
See. This basically conversion is in one step. You are going to name an any alcohol, alkene, and use a suitable reagent to convert into one phenyl ethanol. I think you can draw the structure, the chemical formula or the structure of phenyl ethanol, right? Both of you. Should I explain? Rabia and Aisha. Rabia and Aisha.
Yes, sir.
Okay, see what you are going to do. Let's say there is an alkene and you need to use an alkene with a suitable reagent to make this phenyl ethanol. So this is what your phenyl looks like. Phenyl ethanol, CH2, and then phenyl ethanol it is. So OH will be attached only to this phenyl ethanol. This is your ethanol. So what you are going to do, very easy. We just need to take this. So basically an alkene. This is your benzene because we need benzene. And if you are going to react this with an alkene with a suitable reagent, that means you are going to do the acid catalyzed hydration, H2O, in the presence of H plus. So what will happen here? This H2 will be divided into two parts, H plus and OH minus, and it will follow Markovnikov here. You know that this is the first reaction, preparation of alcohol from alkene you have studied, in which Markovnikov says the negative part will go to that carbon which has lesser number of hydrogen and positive part to that carbon which has greater number of hydrogen. And in this way you can prepare it. Got it? This is your phenyl ethene. So basically, when you are going to treat this phenyl ethene with acid in water in the presence of acid, so this is how you will get. Aisha, very good, both of you. Can we move to the next question?
Yes, sir.
No. Very good. Now the next one is cyclohexyl methanol using an alkyl halide by SN2. SN2, have you studied this? Yes or no?
Yes.
Okay. C6H5CH2Cl. Oh, very good, Aisha. Rabia, any answer? Cyclohexide. No, it's wrong. Aisha, you took the benzene again, but here it is cyclohexide. So you are going to take cyclohexane and then make cyclohexide. Now for just wait a minute. So what you need to prepare from alkyl halide, you need to prepare this cyclohexyl methanol. So this is your scenario in which this part is your cyclohexane, not benzene. Is that clear, Aisha?
Yes, sir.
Now, an alkyl halide, we need this, so I'm just going to take this and you are going to treat this out. Again, benzene, I made it. Now, what you need to do, just take CH2Cl and you are going to treat this with NaOH. So, you know what will happen here. Basically, this is negative because chlorine is more electronegative. This is positive. This will be negative. This will be positive. So this will go and attached with this, and this is how you will get cyclohexyl methanol. I hope this is clear to both of you.
Yes.
Let me know when you are done with this. I'm going to the next question. The third conversion, pentane 1 or using a suitable alkyl halide. Let me know when you are done with this. Very easy it is. I'm going to give a little hint. You can use the same mechanism. What we need to prepare alkyl halide, you need to convert it into pentane 1 or. So it is same alkyl halide into alcohol. So let's say pentane 1 all. So we are going to take pentane, chloropentane, that is CH3, CH2, CH2, CH2. 4 carbon, now it is 5. And you are going to treat this with NaOH, again followed by SN2 mechanism. You will be getting CH3, CH2, 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 and then CH2H. Very easy it is. Rabia, are you able to solve this type of question?
Yes, sir.
Very good. So moving to the next, what do we say? Conversion, or you need to write the name of the reagent. Very easy. We are first focusing first in the first round, focusing on the NCERT each and every question. Then slowly I will increase the level. So here is the question. Name the reagents used in the following case. Oxidation of a primary alcohol to carboxylic acid. Let me know if you're able to solve this, yes or no. Have you studied the chemical reaction of alcohol in which oxidation of alcohol took place? And I think you have studied.
Yes, sir. That's right.
Very good, Aisha. Rabia, any answer from you? So see, it's very easy. If you want to oxidize an alcohol, primary alcohol will be oxidized to carboxylic acid. You need a strong oxidizing agent like potassium permanganate, KMnO4. Acidified, basically this should be acidified, either potassium permanganate or K2Cr2O7, etc. for this. Is that clear? Now there can be another question that we can write. Oxidation of primary alcohol to aldehyde, which the reagent you are going to use to aldehyde. Are not weak, Aisha, moderate oxidizing agent. We use basically, if it is primary alcohol, we use moderate oxidizing agent like PCC. Is that clear?
Okay, sir. Actually, sir, in our class taught us week, so that's why.
Generally, we don't say it weak because we use moderate. We should say moderate. Uh, if sir told you, okay. Can anyone tell me what is the full form of this PCC? Aisha?
Pyridinium fluorochromate.
Iridium fluorochrome. Very important full form it is. Rabia, are you done with this? Or you can call it a weak oxidizing agent as well. But for carboxylic acid, we say it a strong oxidizing agent, which is KMnO4. Okay, call it weak oxidizing agent. The next is also related to the first one, which is benzyl alcohol to benzoic acid. Benzyl alcohol to benzoic acid. Very good. Benzyl alcohol, again 1 degree alcohol converting into carboxylic acid. This is your carboxylic acid. So we need acetified KMnO4 or K2Cr2O7, a strong oxidizing agent. The last one is your butane 2-on. Butane 2-on. Which reagent you are going to use? It is a very strong reducing agent, that's good. But especially for this, we use NaBH4, sodium boron hydride. Basically, lithium aluminum hydride is a very strong reducing agent as well as very expensive. So we generally avoid it due to its expensiveness, and also we can use this. Okay, Aisha, that is also correct. This is also correct.
Okay, sir.
Okay, now we are going for the main conversion. Rabia, are you able to do all of this? Because today you are not giving any answer. Question. How are the following conversions carried out? How are the following conversions carried out? The first one is you are going to convert propene to what? The first one is very easy. I think both of you can easily do it. Very good also. So the first one is very easy. As you can see, you need to prepare propane 2-ol from propene. This is the structure of propene. And if you want to prepare propane 2-ol, you can see this is the scenario. Now, what you need to do, you need to do acid catalyzed hydration. And there will be again Marconico follows OH negative will go to this carbon because it has lesser number of hydrogen. Very easy. Now the next one is benzyl chloride to benzyl alcohol. Rabia, are you there?
Yes, sir.
Okay. Treating with 8% 623. Only say NaOH will be enough, Aisha. After that, you have to follow it by H plus. Okay. So I'm going to write the reaction. You did it correctly. Benzyl chloride. So this is your benzyl chloride. You have to treat this with NaOH. Then you will be getting easily this CH2ON. Basically, there will be positive. This will go and add there. And after that, you are going to treat this with acid, and this Na plus will be replaced by this, and you will be getting benzyl alcohol. Is that clear, both of you? Moving to the third question. Ethyl magnesium. Ethyl magnesium chloride to propane 1-ol. Propane 1-ol. Very good. Very good, Aisha. Rabia, what about you? So you want to prepare propane monoxide from ethyl magnesium chloride. So you are going to write the structure of first ethyl magnesium chloride. So this is the structure of ethyl magnesium chloride, and you want to prepare propane. This already has 2 carbon and this has 3 carbons. So what I'm going to do, I'm going to react this with methanol. I'm going to react this with methanol, and this is the structure of methanol. So if you're going to react this, see what will happen here. It's very simple. Oxygen will take electron from here. It will be negative. This will be positive. This is positive. This is negative. So this negative will directly attack on this, and this positive will go. So this carbon already has 2 hydrogen, and this carbon will be attacked by this CH2, and CH3 is there. And after this, O negative will be with Mg plus and Cl. And after this reaction will be followed by hydrolysis. So you know that hydrolysis has 2 parts, H plus and OH minus, H plus and OH minus. Now this H plus will directly come to this because it has negative charge, and this OH minus will go to this because it has positive charge. So what you will get, CH2OH, then there will be CH2, and then there will be CH3. So this is your propane one-all, and the byproduct will be MgOH3. Is that clear, Rabia?
Yes, sir.
The fourth conversion here is about your methyl magnesium bromide. Methyl magnesium bromide. That means you are going to convert this into methyl propane to all. So both of you are in different batch, right?
No, sir.
Same batch.
Yes, sir. Hmm, very good. Rabia, will you be able to solve this? Okay, I'm going to write it. Very simple. Methyl magnesium bromide is there. That means CH3 MgBr. And you need to convert this into methyl propane to or methyl propane to or. That means
basically 2-methyl to propane 2 also, it will be CH3, which is there, CH3 is there, CH3 is there. How many carbon you can see? There is 4 carbon and there is only 1 carbon. So now, and this is your 2-degree alcohol. Always remember that when Grignard going to react, Grignard reagent going to react with ketone, you will always get 2-degree alcohol. If Grignard reagent is going to react with aldehyde in which aldehyde means methanol. If it is reacting with methanol, then you will be getting 1-degree alcohol. And if Grignard reagent going to react with aldehyde other than methanol, like ethanol, propanol, butanol, then you will get 2-degree alcohol. So here what we need, you can see we have 3-degree alcohol, sorry. Whenever you are going to react Grignard with ketone, you will be getting 3-degree alcohol. Grignard with aldehyde methanol only, you will be getting 1-degree alcohol. And apart from methanol, any aldehyde you are going to use on Grignard, you will getting 2-degree alcohol. So here we can see 3-degree alcohol. That means it's what? It's simple. It's your ketone. It's your ketone. So this is your CH3, C double bond O CH3. Now this will go here and this will have positive, this will have negative. Everyone knows that. This will have positive, this will have negative. So this will attack here. And what we will get CH3C, and there comes CH3, and then there is CH3. Go to O negative, and you will be getting this CH3C, CH3, CH3, OH. So you got the same product, very easy, right? Is that clear?
Yes.
Very good. Rabia, let me know when you are done with this. Okay, the next question. You are going to convert this ethanol, that means alcohol, into butane, or you can call it but1-ine. Very simple it is. Okay, so basically when it comes to fine, you have studied this reaction in class 11, alkyne hydrocarbon. So always remember how we prepare alkyne. This is very important. Okay. So from here to here, what we are going to do? First, I'm going to treat this ethanol and convert this into haloalkane. And how you can do it's very simple. Red phosphorus, or you can use lots of process are there to convert alcohol into alkyl halide. So I'm going to use red phosphorus in the presence of Br2. So this is what you will get, CH3, CH2, Br. Bromoethane you will get. After this, I'm going to react this. You already know magnesium in the presence of ether. So it becomes Grignard reagent, CH3, CH2, MgBr. After getting MgBr, what we need to do? I'm going to react this with another, basically this is your, what we say, CH3, CH2, Br, MgBr, and we, basically you can see here you have 2 carbon and here we have 4 carbon. We need to increase the number of carbon. So what we are going to do, it's very simple. First, we are going, just wait a minute. Can we use anything else? Okay, this will be, okay, I will tell you another method as well. First, you are going to react this with an ether CH2, CH2, O and O in the presence of ether. So with this Grignard reagent, how it will react and what it will form, you can see there will be formation of an adduct, that is CH3, CH2, CH2, and 1, 2, 3, and again CH2, and then OMGBr. Very simple it is. You can see this bond will be broken. There will be negative charge, and then you can see this will have positive charge. So it will attached with this, and it will go like this, CH3, CH2. This is your adduct, basically intermediate. This is your intermediate. After this, you are going to do the hydrolysis, same H plus and OH minus. You know that this will have negative, this will have positive. So this H plus will directly go with this, and you will get an alcohol. That is your butanol, CH3, CH2, 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 OH. After this, we are going to treat this with red phosphorus. You can see red phosphorus in the presence of iodine. Then this OH will be again replaced by, since we took iodine, so it will be replaced by iodine. The OH will be replaced by iodine I. And then we are going to treat this. We are going to treat this with alcoholic KOH, which is elimination reaction. Alcoholic KOH, if you are going to react this iodine, this is your alpha carbon, this is your beta carbon, and hydrogen will be removed, and you will get butene, CH3, CH2, CH, double bond, CH2. After getting butene, what you need to do, very simple, Br4 in the Br2 in the presence of CCl4. So what will happen here? Vicinal dihalide will form. One bond will be broken, and Br will be added to this and this position, and you will get CH3, CH2, and then CH, and then CH2. Br will be added here, and Br will be added here. Is that clear? And after getting this only, what you are going to do, you are just going to react this with NaNH2, sodium amide, in the presence of liquid NH3, and the temperature should be low, cold at least 196 Kelvin. Then you will be getting this Br, hydrogen will be removed, and you will be getting CH3, CH2, C triple bond, CH. So maybe here ether came into play. Maybe you don't understand this concept because you haven't studied, but I can use another method, basically what we say, Wood's reaction. Are you aware of that Wood's reaction?
Yes, sir.
Okay, I will use that as well. First write it and then I will show you. Let me know when you are done with this. Very good. So another method you can use by this as well. You can see we have CH3, CH2, OH, right? So what I'm going to do, I'm going to react this with red phosphorus in the presence of these two, or either you can use PCl3 or PCl5. So this will be converted into CH3, CH2, Cl. And now I'm going to react this with sodium in the presence of dry ether. You know, whatever is the number of carbon, it will be doubled here. It will be doubled here, CH3, CH2, CH2, and CH3. After getting this, what I'm going to do, I'm going to react this. Basically, there will be after getting this, I need alcohol. So I'm going to treat this with aqueous KOH or NaOH. So this OH I'm going to take on this because we need it only. So CH3, CH2, CH2OH, CH2, CH2OH. And after this, what I'm going to do, I'm going to react this with again red phosphorus or I, or we can use this PCl3 or PCl5, and we will get CH3, CH2, 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 Cl. And after this, the same process will be repeated. Alcoholic KOH and heat will be there. Alcoholic KOH and heat, I forgot to write. Then there will be formation of, you can see Cl and hydrogen will be removed. So there will be CH3, CH2, CH double bond, CH2. And after this, again, you are going to follow the same step. Br2 in the presence of CCl4. Br2 in the presence of CCl4. Then you will be getting CH3, CH2, CH, and Br will be here as well as Br will be here. And then the final step, sodium amide in the presence of NH3 liquid NH3. And then you will go. Only I changed one of the steps on. So both of you are in the same batch, right? C3.
Yes, sir.
Rabia. Rabia, can you confirm?
Yes, sir.
You are in C3 batch.
Yes, I'm with Aisha.
What did you say?
I'm in the same batch as Aisha.
Okay, okay. Okay, thank you. No problem. Just write. Everyone is done with this.
Yes, sir.
Okay, so please be prepared with all this NCRT stuff in the next class, because in the next class I'm going to take the level of the question up to JMS, because I had given some question of NEET to you in the starting.